As you know, the Robinson Lecture is an annual event in college where we invite a former scholar of the college to come, someone who has gone on to have a distinguished career, to come and tell us about their work. We love to hear from our old scholars about what they've been doing since they left. So today it's my great pleasure to introduce Professor Tim Lenton, who graduated from Robinson College in 1994 with a degree in natural sciences. He went on to do a PhD at the University of East Anglia under the supervision of Professor Andrew Watson, with whom he co-authored a book, The Revolutions That Made the Earth. And he founded the Global Systems Institute at the University of Exeter, where he holds the chair in climate change and earth system science. He's long been a champion of the view that the Earth and life on it should be understood as a single interconnected global system. Professor Lenton is a member of the Earth Commission and was listed in the top 100 of the Reuters hot list of the world's top climate scientists. So today he will be telling us about positive tipping points to avoid climate tipping points. And with that, I'll hand over to you, Tim.
Thanks, Anna. Thank you for the kind introduction. I'm really sad I can't be with you in person, everyone. Not only the train strike, but the school strikes, leaving both of our children at home, needing their parents to be there, made it impossible to come. But I hope I get a chance to visit another day soon. So I'm going to talk about tipping points, and I suppose, yes, I guess it's a kind of tipping point when your colleagues get to the point of frustration that they feel the need to strike today. Many of mine have. And we are in a kind of winter of discontent, it seems, having lived recently through a pandemic, which itself involved a very marked tipping point in the escalating spread of the coronavirus. And if we rewound a little further before that, wasn't so far back that we went through a major financial crisis 10 or so years ago. So yeah, we seem to be living in times where the world is convulsing, and we certainly, I think, perceive we're in the middle of complex systems that are showing some abrupt and sometimes unpredictable behavior. So yeah, I will talk about some fairly bleak tipping points that might be coming with climate change, but then I'll attempt to cheer you up by telling you a little bit about the positive tipping points that are already beginning to happen, that I think give us the best hope to get out of what some of us call the climate and ecological crisis. Let's start with a movie. So this is a toy model of a system, and it's a system that has two alternative states it can be in. It can only be in one of them, and that's what the blue ball rolling around in the valley. But that state the system started in, I'm the godlike modeler here, and I'm making that state less stable over time. And at some point, the system is going to get tipped out of that state into the other state, which has been getting slowly more stable. There we go. At that tipping point, what's happening is what a scientist would call amplifying feedbacks within the system are taking over, and they're propelling the change. But when we start by drawing valleys, that's a sort of statement that there are some stabilizing or damping feedbacks that want to maintain the status quo in a system. But yes, I'm forcing the system so that they get weaker, and at some point the amplifying feedbacks take over and are going to propel the tipping point change. Now, there are a bunch of complex systems in the world that I already hinted at, the climate being one of them, society being another, and there's a massive scholarship that tries to identify, well, which of the many complex systems in the world could exhibit tipping points. And one can organize those, I suppose, here on time scales and space scales. And I've got a little color coding going on as well. So things in yellow or gold are recognized kind of tipping points in the climate or the Earth system on a whole range of time scales. Things in red are recognized tipping point phenomena in social systems, and the blue, green, and grey are kind of color coding of different ecosystem tipping points that are well known and studied. Bang in the middle is the thing I presume we're all trying to avoid, which would be civilization collapse there, if you can see the digital laser pointer. But yeah, I will start by talking about some of the tipping points in the climate on a global scale. But I want to change direction and talk about some positive social tipping points. So let's start not in deep time, not for an earth scientist like me, but looking across a fair old span of time for most of us, which is the last 650,000 years. Two coloured lines here. The blue one is the carbon dioxide level in the atmosphere measured in tiny air bubbles trapped in ice in Antarctica. And this record has been drilled out of Antarctica. By drilling down, it's drilling backwards in time and then measuring the gas in the air bubbles. But also, if you measure the composition, the ice, you can also get a proxy for temperature at the same time, which is the white line. And you see some characteristic behavior. We call it a sawtooth oscillation for obvious reasons. But what we're looking at are the great ice age cycles that each cycle lasting roughly 100,000 years. And if I hadn't told you what the traces were, and I sort of scrubbed off the labels on the axis, and I just gave you those two traces, and I asked you if this was the signature of a stable system or an unstable one. If you're an electrical engineer, for example, or possibly a cardiologist, I think you'd say to me, this is not a particularly stable system, because in general, systems that do this kind of sawtooth oscillation are ones where there are strong amplifying feedbacks within a system that are propelling change. In this case, it's at the end of each ice age that ends abruptly. But there are still some damping feedbacks that set the bounds on the system, the depths of the ice age or the warmth of what are called the interglacials. But yeah, the take-home message is that Earth's climate was, I would say, unusually unstable when we evolved, came along, developed agriculture, civilizations, and started the Industrial Revolution and pushed the CO2 concentration up to roughly there, about 420 parts per million of the atmosphere today. And if we carry on the way we're going, possibly off the top of the chart in the rest of my lifetime, let's hope not, because knowing there's sort of natural instability, we ought not to be surprised if I argue for the next 15 minutes that we could trigger a load of instabilities and tipping points in the climate system if we push things that hard. And of course, we should expect the temperature to follow. I mean, after all, look at how it's in lockstep with the carbon dioxide concentration naturally. Now, if we turn to projections of temperature globally going into the future from the famous Intergovernmental Panel on Climate Change, well, they could go a number of ways, and this sort of spans the range expected this century. But the thing that always nagged me about these projections, they look kind of smooth. Now, this back over here in black and grey is the historical temperature record. Not as smooth as the projections, some interesting structure in it. And that sort of sense of smoothness, even if it's up to high levels of warming like 4 or 5 degrees centigrade, might bring a little bit of a false sense of security. Because as we're about to see, even if the global temperature were to change smoothly, there could be some very abrupt changes in the climate. And just for reference, in the depths of the last ice age, the global average temperature was about 4 degrees centigrade cooler than the pre-industrial, where this graph starts. So you can see that we could be creating this century a magnitude of climate change comparable to that between the last ice age and pre-industrial time. And for reference, that past change included about 120 meters of sea level rise and a complete reshaping of the face of the Earth. So let's look into the climate models that we were just staring at that kind of give those, when you average over the models, they give those kind of smooth lines, and the different colored lines and the different amounts of warming are principally determined by how much greenhouse gas, principally carbon dioxide, we cumulatively emit. Now, if we look into those projections, we look into the model worlds. Models aren't perfect, but the models do convulse and they do show tipping points and abrupt changes in different places. And this is just a visual summary of some of the places in model world where abrupt changes happen. And the color key is the level of warming above the pre-industrial that they happen at. And we're at about 1.2, possibly 1.3 degrees of warming at the moment. And if you've got your eye on the color scale, worryingly, a bunch of things are in yellow, indicating that in model worlds, there's a prediction of lots of abrupt changes in the temperature range we've already entered into. And you also see spatially they cluster. So I might say a word more in a minute about what on earth might be going on in the seas near Greenland, the Labrador Sea, for example, here. But first, let's turn to empirical data, because the other thing that gets us climate scientists alarmed is the fact that change is accelerating in the wrong direction in a bunch of parts of the climate system, what I call tipping elements of the climate system, because even 15 years ago, we'd already identified that these systems could exhibit a tipping point, and we were pushing the climate towards the tipping point for these systems. So we don't need to go all over the map to see that there's lots of accelerating change in the wrong direction going on. The most depressingly persuasive evidence for a climate tipping point is in the retreat of part of the West Antarctic ice sheet. It's going in a self-propelling way, arguably already. That part of the ice sheet drains the equivalent of about 1.3 meters of global sea level rise. If our models are correct, though, if you destabilize that part of the ice sheet that might already be going, eventually it will destabilize the rest, and they give about 3.5 meters of sea level rise. The Greenland ice sheet is also losing ice at an accelerating rate. There's 7 meters of sea level rise locked up in the Greenland ice sheet. The only saving grace here is that ice sheets take a long time to melt, but they melt faster the more you warm them up, and they melt faster if a tipping point change gets underway, where a reinforcing feedback self-accelerates the ice loss. One thing I will be saying a bit more about in a minute is the slowdown of the great, what we call the great overturning circulation of the Atlantic Ocean. It brings warm waters from the Southern Ocean and the Southern Hemisphere across the equator into the Northern Hemisphere, and then deep waters form. The surface water gets salty enough, cold enough, and dense enough to sink from the top of the ocean to the bottom, either side of Greenland. And then there's a return cold flow back at depth. That great circulation has slowed down markedly, and it's well known that that can have tipping points that are implicated in past abrupt climate changes. So all of this is part of a general story that as us climate scientists look harder at the climate system and watch it for longer, our assessment has raised the red flag of alarm about climate tipping points further and further up the proverbial mast, if I can put it like that. Basically, 20 years ago, when I started working on this stuff, the scientific assessment was that it would take 4 or 5 degrees C of global warming before there was a sort of low to medium likelihood of some of these bad climate tipping points kicking off. As of about 2018 and 2019, we'd reassess things collectively, and we already acknowledge we're in kind of the danger zone for some of these climate tipping points. And going to 2 degrees C of global warming, which used to be thought to be a safe level, now looks distinctly dangerous. Looks like, well, we might expect a number of tipping points. So just recently, we've been trying to remap out where those bad tipping points might happen. This is one of 2 maps I'll show of the systems or tipping elements, I call them, in question. I've been telling you a bit about the Atlantic overturning circulation, and that's going to return again in a minute. Scientists talk about it in terms of an acronym from the leading letters. They call it that AMOC, the Atlantic Meridional Overturning Circulation. And in part of that is the sinking of surface waters to depth over here in the Labrador Sea. And just as one example of a tipping point, that one, if it goes, it would give us a transition like the transition that happened historically to the Little Ice Age in Europe. It would raise the sea level at Boston and New York by 20 or 30 centimeters. It would disrupt the monsoon in West Africa, potentially severely, and that all could unfold in about a decade. There's also what that last map was a bunch of things where if you tip them, you kind of know about it globally. It changes the global climate in some sense. On this map are a bunch of other tipping elements that may not, if you tip them, change the whole global climate, but by my word, a lot of people would know about it. So, for example, coral reefs in the tropics are already being bleached repeatedly and severely, and about 500 million people depend on them for their livelihoods. I won't go through everything. I'll just turn to our summary that we published last autumn, where we just lined up all these tipping elements, the systems that could have a tipping point. We lined them up in terms of the best estimates we could make of where the tipping point is on the y-axis is the global temperature change. And we did this compiling something like 230 published studies, a lot of stuff from past data, from models, so on and so forth. Again, the burning embers, as we call them, they start going yellow where you have, for example, one model predicts the tipping point of the Greenland ice sheet is already past, that it happened at 0.8 degrees of global warming. The current warming levels marked on there. You can see that even at the current warming level, our best assessment is 4, possibly 5 systems are already at risk. Our dotted lines here are our best guess where the tipping point might lie. Unfortunately, 4 of them are at 1.5 degrees centigrade of global warming, a level we'll be at possibly in the next decade and will be very hard to avoid now. And the big tragedy is there's a sort of whacking grey line across here, which is where current policies of all the nations of the world are taking us to about a little bit over 2.5 degrees centigrade of global warming, if they make good on their policies and promises, at which point, I think by my count, there are maybe 13 tipping points at risk. Few of them we'd be pretty sure we'd be well past. We'd be in a world of really high impact climate change later this century. And I know this is depressing, but I'm afraid it gets worse because, like all complex systems, the climate is interconnected. And so if you tip one thing, well, it's probably going to have a causal impact on another. That doesn't have to be coupled in a bad way. Hypothetically, it could be the case that you tip one thing and it makes it less likely to tip another. But unfortunately, there's a preponderance of the opposite kind of connection where you tip one thing in the climate, and evidence from Earth's past, at least, would suggest it makes it more likely to tip another. So just to talk about that causally, the Arctic is warming about 4 times as fast as the global average because of the extraordinary melt of the Arctic sea ice and the snow on the land surface. It basically exposes a much darker surface than was present and absorbs far more radiation from the sun, and hence the amplified warming. Well, that means a couple of things. That amplified warming is contributing to the Greenland ice melting and the permafrost thawing, which adds carbon back to the atmosphere. Warmer Arctic means moister atmosphere, means more precipitation. So you have rain and snow increased falling from the sky, and you have meltwater, fresh water pouring off Greenland into the North Atlantic. And that makes the surface of the North Atlantic fresher, and that inhibits it from sinking. Because remember, the surface waters naturally, they get salty and cold enough and therefore dense enough to sink from the top of the Atlantic to the bottom on either side of Greenland. You add fresh water to the salt water, and it inhibits that because it makes the surface water less dense. That's a big reason why this Atlantic circulation is slowing down. Unfortunately, Earth's past tells us when you slow that down, you drag the rainfall band around the tropics southwards, disrupt the monsoons, including for the Amazon. And if you slow the circulation down, you take less heat away from the Southern Ocean northwards. You leave it behind. Leaving the warmth behind is bad news for the ice sheets because it's the warmer ocean which is threatening the collapse of the West Antarctic ice sheet, for example. So, pretty sobering stuff. And if you're curious about, well, what are the impacts of one of these tipping points, I have to tell you that hasn't been as studied as it should be, but we've done some work looking at what happens if this great Atlantic overturning circulation that seems to connect the climate system together, what happens if that tips and switches off on top of the 2.5 degrees of global warming that we should expect based on current policies? Well, the world sort of has an interesting pattern of temperature change. If you get that tipping point, it radically cools the North Atlantic region, even though the globe is still warming up. But the effect on the water cycle is even more profound. So basically, red areas is big decline in precipitation, blue is a big gain. They're in, percentage changes here. So that amounts to 50% or so decline in rainfall in Indian summer monsoon region and in West Africa in that monsoon system, and tens of percent decline in precipitation right across Europe and major crop growing regions. So we started to look at, okay, well, what would that do, that tipping point together with global warming, to, for example, agriculture in the UK? Agriculture in the UK looks something like this at the moment, with brown being arable farming and green being less profitable pasture raising of livestock, etc., grasslands. Basically, if we had that climate tipping point, it wouldn't be the cold that would get us, but it would get so much drier over the UK that you'd eliminate arable farming, essentially. That would be the least of our worries, because by our calculation, the southeast of the country would be in a water crisis, Cambridge included, I'm afraid, because they're literally, there'd be a serious water problem because it'd be so much drier, particularly all year round, but particularly in the summers. And we calculated you'd need a massive infrastructure project. You need to put an enormous pipeline under high speed 2 to bring water from where it would still be raining in the mountains in the west and the Lake District down to the southeast where all the people are. So that's the local picture. Globally, this tipping point on top of global warming, it would do very detrimental things to the growing area for major crops like wheat and maize, although for rice it's a mixed picture. Purple is where things get worse or less viable for particular crops, and green is where they would get better. When you tally it all up, it turns out that global warming and climate tipping point have kind of additive effects in a bad direction for crop growing feasibility. And the viable area for growing wheat on the planet more than halves, and the same is true for maize. So in short, there'd be a massive food security crisis if this were to happen. So that's enough misery, plenty misery for me. Now let's try and turn things around, and let's talk about what do we need to do to minimize those risks, because any sane person listening to the first part of the lecture is going to be thinking, right, we better do something about this. I think you've heard the language, hopefully, of net zero and the fact that we need to stop going up the green line of global increasing greenhouse gas emissions and come down something like the red line. eliminate all fossil fuel burning, all greenhouse gas emissions by the middle of this century. And then do something no one's quite sure how to do, by the way, which is try to get into a situation where we're doing net greenhouse gas removal on an extraordinary, almost imaginable scale later this century. Well, let's focus on the immediate challenge. It amounts to trying, if we wanted to hold the line at 1.5 degrees C of global warming, it would amount to halving greenhouse gas emissions globally by the end of this decade. None of us think we're going to make that, but let's try our hardest. The point is, to get anywhere near that, we'd have to accelerate the change of technologies, etc., that's required by about a factor of 5 globally. And the only way I can see of achieving that kind of acceleration is to find and trigger some what I'd call positive tipping points that switch us away from fossil fuels to alternative energy sources and all the rest. And that's what I want to talk about for the rest of the lecture, because as we'll see, this isn't just a cartoon, although many of us do draw this same cartoon that we're stuck in a business as usual state of the economy powered by fossil fuels, but there's some other decarbonized state we ought to try and get to. It's not just a cartoon, as we'll see. There really is some evidence that that other state exists and that there could be reinforcing feedbacks that would propel change to this different state of society and economy. And the trick is to work out, well, what are these things, the interventions that could enable that transition if we agree that we need it. So to talk about that, I want to start with a distant relative of mine. I want to talk about how there's that we can change fast and we have changed fast in the past. So this is Lillian Lenton. This photograph is taken in 1913. And you'll see the number on her jacket, which might give you a clue to the fact that she's in prison at the time. And if you know your social history, you can guess already why she was in prison in 1913 in London. It's because she'd been strongly implicated in burning the tea house in Kew Gardens to the ground as one of the many direct actions by the suffragette movement, of which she was an instrumental part. In prison, Lillian, like many suffragettes, went on hunger strike. And the suffragettes who went on hunger strike were force-fed. Unfortunately, they put the tube down the wrong way, not into her stomach, but into her lungs. Medics in the audience will know that that's like drowning somebody. Well, Lillian survived that. And she was, of course, rushed to hospital. The government tried to cover up what had happened, argued publicly that she was only in hospital because of the hunger strike. It became immediately apparent that that was a lie. That was one of many little events that turned public opinion against the then government and in favour of the women's suffrage movement, which yielded the vote for women aged, I think, 30 and over in 1918. That did not please Lillian because she was under 30 still at the time, and she had to wait quite a few more years before she got to the right to vote. But of course, the point is, those brave social activists ultimately led to a profound social change, doubled the democratic voting population of the nation in a movement that spread worldwide. And more recently, we've seen other examples of extraordinary social tipping points, started by this remarkable young lady. You all know who she is now, Greta Thunberg. Now, by choosing to skip school on a Friday to protest the Swedish Parliament's lack of action on climate change, Greta made it incrementally easier for the next person to also skip school or work and join her in a protest, which made it incrementally easier for the next person to join, and so on and so on. This is a classic reinforcing or amplifying feedback loop. And within months, there were millions of us marching on the streets demanding more decisive policy action on climate change. Academics talk about that phenomenon also in the language of social contagion. But it led to political action within months. This is the European Parliament declaring a climate emergency in November 2019. But as Greta would remind us, the climate system can't hear political rhetoric. It can only feel the difference if we actually reduce those greenhouse gas emissions. So we've also, as well as believing that we can sort of change our norms, our values, and sometimes our political declarations quickly, we've got to believe we can change the technologies and the behaviors that are causing the problem in the first place, climate change, quickly. So we've got to believe we can change technology fast. And to help believe that, let's look back in the past. This is a photograph of the Easter parade in New York City in the year 1900, Fifth Avenue this is, and your challenge is to spot the person driving an early automobile when everybody else is in a horse-drawn carriage. If you've got good eyes, you will find them already over here near the middle of the photo, coming towards us on the right-hand side of the street. But the interesting challenge comes 13 years later. If we look at a photograph of the same Easter parade on the same street, Fifth Avenue, New York City, in the year 1913, your challenge is to spot the person left in a horse-drawn carriage when everybody else is driving an automobile. It's a bit easier in this shot, and they're in the same place on the street over here coming towards us. Now that was a profound tipping point in means of personal transport or mobility that unfolded within a decade across US cities and of course spread around the world. Probably one that we would sort of rue now if we're a climate scientist. But incidentally, partway through that great transformation, there was a time at which 30% of the early cars were battery electric. And legend has it that it was Thomas Edison of light bulb fame who talked his friend Henry Ford out of the electric vehicle and into the internal combustion engine. And the rest, as they say, is history. Now, that was just there to show us that, wow, we can change technology fast. And to hammer the point home, here's a bunch of graphs of the uptake of new technology across US households over the last century and a half. And they all show what's called an S-curve, a characteristic shape where there's a time of really exponentially increasing uptake of new technology, and it can become dominant within a matter of years in some cases. Now, this can only be explained by the fact that there are well-known reinforcing feedbacks propelling change. We call them things like learning by doing. The more we make something, the better we get at making it. Or economies of scale. The more we make something, the cheaper the next unit of that thing gets to make. And then there's another more subtle thing, that when we have a new technology, more technologies emerge or get invented to make the parent technology more useful. Right now, you could think of that in terms of, well, electric cars depend on there being an electric charging network. It's a complementary technology. Which brings me to the electric car, which, as we heard, failed to achieve dominance in the 1900s, but I will argue is experiencing its tipping point now. And the first country that's tipped to electric vehicles happens to be Norway. And the various characters in this photograph, taken in 1989, 2 years before I came up to Robinson College, were instrumental in why tiny little Norway has been the first tipping point for electric cars. Now, some of you might be old enough to recognize these couple of these characters. For undergraduates of my generation coming to Robinson, we'd grown up on the music of this guy, Morten Harket, and his fellow band member and the band Aha. He's also an environmentalist, and these are a couple of his friends, and another, both of them environmentalists. This one in the middle, particularly significant, Harold Rosvik. He's also an architecture professor in Stavanger in Norway. Between them, they have purchased in Bern in Switzerland this red vehicle. We'd call it a Fiat Panda, but it's not a normal Fiat Panda. It was a hobby converted electric vehicle. And they had a plan to take it back to Norway, but with a bunch of demands for the then government led by Gro Harlem Brundtland, who was famous for something called the concept of sustainable development, the Norwegian Prime Minister. They wanted to persuade the Norwegian government to put their money where their mouth was and incentivize clean transport in the form of electric vehicles, as well as more energy efficient homes and solar power and a whole bunch of other things. And yet, that was in 1989. And because they were a pop band as well as a professor and an activist, they knew the media would be following them around everywhere they went. And therefore, if they made public what they were doing and a series of demands to the government, they might get some traction. And that's what they did. Their demands included a demand that Norway waive the import registration tax for all electric vehicles, which is quite a big deal because that's about 20% of the cost of a vehicle in Norway, where no one makes cars anyway. They also demanded that they waive road tolls for electric vehicles from then onwards. They had 7 or 8 other demands. They only got the first demand initially, but that started to create what I'd call enabling conditions for a tipping point. And after 8 years of fighting, they eventually got the road tolls waived for all electric cars, and so on and so forth. And in fact, the government sort of slowly came on board and got behind the change that began to happen, such that now if you go to the streets of Oslo, you'll see it looks kind of like this. And this is a photo from a few years ago, actually. And here's the data. The pale sort of sky blue is the market share of pure battery electric vehicles. And this is just through 2020. It went from sort of nothing to over half in a decade. It's now at about 85% in Norway. All traces back to those social activists and what they started. And it's important more globally. It gives us some ideas about how this tipping point could spread. And behind it is a crucial thing, what I would have referred to as economies of scale, is the fact that the more batteries for electric cars get made, the cheaper the next battery gets to make. And over the last 10 years, batteries have declined in price about tenfold. Well, that feedback is going to become strong enough to be self-propelling. But for now, if there were more progressive government support, as we're beginning to see across Europe for the switch to electric vehicles, well, then the more electric vehicles get made, the cheaper the next one is going to get to make, and so on and so on. So we can quite readily see now this tipping point spreading to the point where, because they've got fewer moving parts, electric vehicles are destined to become cheaper to manufacture than petrol or diesel cars quite soon by most estimates. Then everyone will be buying them. But then that opens up other possible tipping points, like the obvious ones. You've got loads of cheap batteries available, and they're getting ever cheaper the more you make. Well, why not electrify light goods transport? Slightly more radical. At that point, oil firms, and they're already thinking this, realize that they're sat on what's called stranded asset. They thought they were going to sell a bunch of oil that they know about in the ground, but they're not going to be able to because there'll be no cars left on the road to run it on. So they'll start reinventing themselves. Arguably, that's happening already. But perhaps the most profound tipping point is that having lots of cheap batteries available is like cheap electricity storage. And that's the key thing you want for another major tipping point, which is the switch to renewable power. Because the one problem you have to solve in a renewable energy world is when you go to your room after lectures and you want to boil the kettle, it's not necessarily when the sun's shining or the wind's blowing. So you need cheap storage in the grid. Which brings me to a second good news story, which is how we've already seen a tipping point towards renewable energy and away from coal burning in the UK. So the black line is the contribution of coal burning to UK electricity, power generation over time. And in 2012, at this little peak here, that's about 40% of our electricity from burning coal. Today, it's probably about, on average, 1%. And that tipping point, that shutting of coal burning out of power generation in the UK, it's got a few things behind it, including taxpayers' money being invested in the green, blue, and the yellow here, the expansion of renewable power. But also it took just a modest price on carbon emissions just levied in the power sector to tip what's called the merit order in the power sector away from coal burning, because coal is always the dirtiest form of electricity production compared to, say, gas. For the same power generated, twice the greenhouse gas emissions from burning coal as burning gas. So if you put a price on greenhouse gas emissions, carbon in particular, you can shift things around so that once you've used up all the renewable power on the grid, the thing you're going to do is not switch on a coal power station, but switch on a gas one instead. Well, that was really starting to happen here as the government levied a modest price on carbon in the sector, and as a big part of that precipitous decline. And this is a utility analyst talking about it in 2016. What happened then was the people who were invested in coal burning weren't making any money. So surprise, surprise, they started to pull their investment out of coal and coal power stations and all the rest. And that triggered reinforcing and irreversible changes, because then the utility companies thought, we're not making any money with these power stations. They cost a lot to just leave idle. Let's start destroying them. So that's the destruction of the coal-fired power station in Didcot in Oxfordshire, a kind of iconic example that we've gone through an irreversible tipping point and we're never going back. Now, there's more to it than that. We're seeing now also the uptake of renewable energy technology spreading through what I referred to earlier as social contagion, particularly for solar panels that you can put on the roof of your house. People tend to follow and copy each other in the putting of solar panels on roofs. And that's illustrated here with a little movie that spools through the early mid-2000s in a part of the USA where you're just seeing first-time customers in yellow and referred customers in green taking up solar PV panels. This is a social contagion that continues at the moment, particularly because the price of solar panels has been coming down absolutely spectacularly over time. So when I was at Robinson College, it wasn't looking so great. This is a plot of the price of solar panels on the y-axis on a log scale compared to the number of solar panels that are being produced on the x-axis on a log scale. And in the 1990s, it had all sort of stalled. But after a big injection of private capital, floating of 5 companies on the US stock exchange, there was a sudden extraordinary change where the so-called economies of scale kicked in, and solar panels have got, well, more than a factor of 10 cheaper within the last decade. And all leading analysts project they continue to get cheaper into the future. And this is our salvation, quite possibly, because solar and in the UK, wind power on and offshore, they're already able to generate electricity, in the case of wind power for the UK, cheaper than anything else. But in the global context, renewables are going to be generating power at a quarter of the price fossil fuels ever have or ever will by the end of this decade. And even a couple of years ago, as this map shows, the cheapest source of new power generation for electricity, country by country, tended to be renewables, solar in yellow or wind in blue, compared to fossil fuels in grey or black, if you took away the perverse subsidies and tax credits that still favoured fossil fuels and still do favour fossil fuels. This map, by the way, continues to get better all the time. So a tipping point is underway to renewable energy, and a tipping point is underway towards electrifying transport, and I think electrifying everything else that it makes sense to electrify. And even better news is that those two first tipping points reinforce each other. I explained how the cheaper batteries enable the shift to renewable energy, but if renewable energy is now generating electricity cheaper than fossil fuels ever have, and it just keeps getting cheaper, then wow, it makes a whole lot of sense, first of all, to electrify the car fleet to make it cheaper to run, but then to electrify everything else you can. Where you can't, to use the renewable energy to split water and make what's called green hydrogen, and then use that where that's the sensible option, and so on. The point is, we could be seeing the beginning of tipping points, positive ones, cascading across the economy. I'm having a look at the clock, and I think I might have used up my 40 minutes. So luckily, I'm near the end. That was very techno-centered. I just wanted to say that, well, we also interact with ecology, other living things. Ecosystems are full of their own tipping points just naturally. An iconic example is what happened when wolves were, first of all, extinguished in Yellowstone National Park. It changed the whole ecosystem, and then reintroduced, it changed the whole ecosystem. The broader point here is, if we want to eat, we have to interact with ecology, other living things. And other living things like these edible blue mussel beds are kind of wonderful. And in this case, you can see they do something wonderful. They create their own spatial patterns. They stabilize the muddy sediments upon which they grow. They create their own flourishing. They create a larger mussel bed, if you like. And very crude technology in this case, like sticking in fences, gives them something to hang on to. And then their own self-reinforcing feedbacks can generate a much bigger and sustainably harvestable, in this case, blue mussel bed. That's just one example, but I've been busy working on a number of other examples of positive tipping points that we could find in Trigger to transform food and land systems. Also, most recently, we just put out a report on identifying positive tipping points and the positive tipping cascades across food, land, energy, transport systems, the works. So to wrap it up, what I'm trying to say is it's easy to feel scared and disempowered in the face of climate change, but happily, we don't have to put our life on the line, like my relative Lillian, in order to be part of making the change we need. We're all consumers. We can all make choices about what we consume, about where our money is invested, and so on and so forth. And thus, we've all got some kind of agency to be part of what I'd call, first of all, creating the enabling conditions for the positive tipping points, and then actually tipping them. And we'll probably be most effective if us members of civil society form a sort of holy alliance with some sensible policy, some movements of capital, and, as we saw with the AHA example, having the media tell our story of change. So I'll wrap it up there. I've basically just told you the bad news that we're in a climate emergency, and that our last and best hope of doing anything serious about it is to find and trigger some reinforcing feedbacks and some positive tipping points. But I hope I've cheered you up by showing you that some of those are already happening, and we could all get on board with creating some more of them. Thanks a lot.
Thank you very much. I would now like to ask my two volunteers. So I will open this up to questions from the audience. If you would like to ask a question, please raise your hand and wait to be handed a microphone. Any questions? Anyone here?
Someone's feeling brave.
Can I ask whether there wasn't more sort of discussion if in the talk and like in the literature in general, it seems, in terms of nuclear energy as an alternative source?
Yes. I didn't talk a lot about it because of all the energy sources we have, it is the only one that has ever got more expensive over time. So I talked about learning by doing. People now talk about it as like reverse learning by doing in the case of nuclear power. Now we can debate at length why it's been busy getting more expensive over time, but it was a pragmatic choice on my part. Like many people who are trained in physics, in my case at Robinson, I'm quite sympathetic to nuclear power. I always thought it would be a key part of the energy mix, and it still will be for providing what we've called baseload electricity. But it's not going to be the dominant thing for very blunt economic reasons. And if you look at Hinkley Point C and how much that's going over budget, you'll probably agree with me that it's a hell of a hit for the taxpayer. It's got a so-called strike price, which the government is guaranteeing to pay for the electricity generated. It's something like, I might get my figures wrong here, but it might be 90p, is it, per kilowatt hour? I might have my units wrong. That's at more than, well more than twice what offshore wind is generating at already. Yeah, so way more. So it's expensive, is the simple answer, really expensive. And I think we should be willing to pay for some of it, but I see no chance it will dominate when renewables are now getting so cheap and they're getting so much cheaper.
Questions over there?
Do you worry that with a new coal power plant, alongside I think 2 others being approved, that we could regress backwards possibly, or do you think this will be a blip and then we'll keep progressing forwards from there?
I do worry that we're regressing with the incumbent government, but I get some heart from the fact that I think it's a kind of sop to a particular fraction of the electorate, or at least I hope it is, because in real terms and real money, this government and certainly the civil service is still intent on rolling out offshore wind in the North Sea as much as we possibly can. So if you look at our targets for offshore wind for 2030 for the UK, they've been creeping up all the time as we realise how much more potential there is and how much the price is coming down. I think it originally was set as a 30 gigawatt target, and now we're probably going to push 55 gigawatts out of the North Sea wind power by the end of the decade if we're lucky. And just for reference, last year I think wind was already, mixture on and offshore this is, but was already a quarter of our electricity supply. And I forget the exact fraction, but 55 gigawatts would probably be more, well, be well over half, 2/3 or something, maybe even more than that. So basically, I'm like you, really sad that we have these kind of backwards looking silliness around the coal plant in Cumbria and the coal mine in Cumbria, sorry, and also licensing new fossil fuel extraction in the North Sea. But I think luckily those things are kind of tiny compared to where the real action is.
Further questions? Yeah.
Hi, it was nice to hear your positive reinforcements and tipping points, but I also wanted to sort of come back to your bobbling blue model, and you said that there was sort of systems that maintained the status quo, and I think you mentioned one of them, which was the absurd subsidies for fossil fuel use and extraction. Are there others that you would highlight that need to be eliminated, as well as focusing on the positive?
Indeed, yeah, and that might be one of the biggest ones. Particularly when it's our taxpayers' money, basically subsidising something that actually is to all of our collective detriment and our children's and so on and so forth. But on top of that, one would also ask questions of private finance, as some prominent celebrities have gone public on in just the last week or so. Why are some of our most famous high street banks, whilst they tell us in their adverts this sort of greenwash story of what they're doing, they're still heavily investing in new coal plants and new fossil fuel plants? And that has to be called out, and I think we need an open, public, sort of transparent information on this. And then I think, all sorts of actors, us as pension holders, pension fund themselves, asset managers, there's a whole apparatus in the financial sector that is waking up, or if it hasn't already woken up into this, and we might see, let's hope we can create and see change there. But right now, the point is still a lot of private capital and investment going in the wrong direction. Beyond that, one would refer to things like it's a bit generalization, I suppose, to talk about lock-in effects and sunk costs, but in civilizations in general, we get a lot of inertia. We get a lot of we get locked into habits of behavior as individuals, but culturally we get locked into ways of doing things, and that manifests in so many forms. It would probably be a long discussion to list them all, but I would say I have stopped flying for at least 3 years now, and I'm quite enjoying it. But that it isn't always that easy even to change personal behaviour just because we're creatures of habit. So I guess it would be a very long answer to give you a full one, but I kind of see multiple levels and layers at which we get locked into things that we might in our heads say, maybe we need to change. Doesn't mean change is easy. So yeah, of course, this is much of this is also a matter of politics at the larger level, and one only has to look at the rise of populism to see that this is kind of the political battleground now anyway. And well, it would be a long discussion to talk about what might have been going through President Putin's head in waging this awful war in Ukraine, but several studies had made absolutely clear in the last few years that among the fossil fuel major producers and exporters, Russia will be one of the ones to suffer the most if the faster this transition that I think should happen does happen. And through the war, they have caused a number of repercussions. We had maybe a wider debate to talk about which way that will go. But I was just making the point. I think that some incumbents in power are fighting hard to maintain a particular status quo. Others, President Biden with the Inflation Reduction Act, are making pretty bold moves to propel this transition faster. China's also doing a lot, and as you might have read yesterday, the EU are now kind of realizing they're playing catch up against the US and China in this kind of green transition.
Are there further questions? Yes, for that.
Can I ask you about a specific thing? What about Drax? Is Drax a good idea or a bad idea? Is it good or terrible?
I'm appalled that they are, personally, as has become apparent, they are not. They say they're sourcing only secondary forests from Canada, but it's become apparent, thanks to investigative journalists, that that's not wholly true. I don't know. I guess none of us are quite sure what the fraction of primary Canadian forest is that's going into wood pellets that are coming across the Atlantic to Drax. But the tragedy is it's not 0%. Yeah. If this were being sustainably sourced, these wood pellets feeding Drax, then I wouldn't be so troubled by it. But right now, I think it's not. Yeah, I've said my piece. I think it's something to be ashamed of. Actually, it's not that bioenergy couldn't or wouldn't have some role to play in the future energy mix, but to think about it as a natural sciences undergraduate might have been taught to, the efficiency of conversion of sunlight into useful energy going via plants, whether they're trees or whatever, through photosynthesis. You might get 0.2%. In optimal conditions, you might push 1, maybe 2%. Just your cheapest bog standard solar panel, at least 20% efficient. Now some are pushing 25 and above. It just doesn't, in the big picture, ultimately it makes no sense to favour biomass over just straight solar PV as a way of harnessing the sun's energy.
Okay, thank you very much. We're out of time. So
apologies that
yes, thank you once again, Tim. We will now carry on to a drinks reception and the dinner, where unfortunately you will not be able to join us.
Magic.
Thank you very much for that really, really enlightening talk.